Dear students, this video will help you to learn how to use screw gauge. Screw gauge is also known as micrometer and it is a precision instrument. It is used for measuring thickness of an object and diameter of circular objects with an accuracy of 0.01 millimeter. Various types of micrometers are there and different sizes also available like 0 to 1 inch, 0 to 2 inch, 0 to 3 inch and 4 inch, 5 inch like that. And digital micrometer is also there. Now you can see a classical screw gauge mostly seen in all the physics laboratory. First let us see some of its parts. This is the part called spindle. It is a moving end and this is fixed end and it is called anvil, and this is the pitch scale. In pitch scale we have reading from 0 to 20 mm. Then we have head scale. It is a cylindrical scale. In head scale there are 100 divisions and this is called thimble, and this is the part called ratchet. Now we will look at the pitch scale closely. Now we are able to see the pitch scale. It consists of 0 to 20 millimeters. So we can measure up to 20 millimeter using this screw gauge. And here in pitch scale this is the 0th mm, and next we have 1 mm division, and then 2 mm and 3 mm, 4 mm, 5 mm like that. Up to 20 divisions are there in pitch scale. And now you are seeing the head scale, and that is the 0th division, 1st division, 2nd division, 3rd, 4th and 5th division is somewhat lengthy. So like that there are 100 divisions in head scale. What is least count? Least count of any measuring instrument is the smallest quantity that can be measured accurately using that instrument. For example, this is a 150 ml beaker. The smallest quantity that can be measured using this beaker is 25 ml. So the least count of this beaker is 25 ml. And another example, this is an ordinary wooden scale. The smallest quantity that can be measured using this wooden scale is 1 mm. So the least count of this wooden scale is 1 mm. Now let us take the case of screw gauge. One revolution of head scale covers 1 millimeter in pitch scale. That means 1 millimeter is divided into 100 divisions. Then the least count will be 1 by 100 mm. That means 0.01 millimeter. Before we use screw gauge, we should check for the error. There are 3 possibilities. One is no zero error, second one is positive zero error, and third one is negative zero error. Now we will see one by one. The first case is if the reference line and zero of head scale coincides each other, then there is no error in screw gauge. The reading observed from this screw gauge can be taken as final reading and there is no need for any correction. So now you are able to see 0 of head scale exactly coincides with reference line. So there is no error in this screw gauge. Now the second case is when the screw gauge is fully closed. Now you can see the 0 of head scale is below the reference line, and this type of error is called positive zero error and the correction will be negative. Here the 9th division exactly coincide with the reference line and the head scale coincidence will be 9 division, and zero error can be calculated by multiplying least count with the head scale coincidence. So the zero error will be 0.09 millimeter and the zero correction will be minus 0.09 millimeter. When this type of screw gauge is used, we have to subtract the zero correction observed reading. Now the third case, when the screw gauge is tightened up. Now you can observe the 0 lies above the reference line and the 95th division coincides with the reference line. So this kind of error is called negative 0 error and the correction is positive. Here the head scale coincidence is 95th division and the 0 error is calculated by subtracting head scale coincidence from 100 because the head scale consists of 100 divisions. Now 100 minus 95 and that is multiplied with the least count 0.01 millimeter. So we get 0 error minus 0.05 millimeter and the correction will be 0.05 millimeter. This is the consolidated view of three possible positions in screw gauge. First one, the reference line exactly coincides with the 0 of head scale and in this case no error and no correction is required. And second case, the 0 is below the reference line and this is the case called positive 0 error and the correction is negative correction. And third case, 0 is above the reference line and this is called negative 0 error and the correction is positive correction. Now we will measure the thickness of a pencil. The pencil is placed in between the spindle and anvil and tighten up gently by ratchet. Now we can observe the reading. The 7th millimeter is seen on pitch scale reading and 78th division coincides with the reference line. The observations are pitch scale reading 7 mm and head scale coincidence is 78th division. Calculation. The formula is observed reading is equal to pitch scale reading plus head scale coincidence into least count. We can substitute the value and we will get the observed reading is 7.78 millimeter. And we have to apply the correction. The corrected reading is obtained by the formula corrected reading is equal to observed reading plus or minus 0 correction. And let us consider the 0 correction is 0.05 millimeter. We will get 7.83 millimeter and the thickness of the given pencil is 7.83 millimeter. The next example is the measurement of diameter of an electrical tester. Now the object is placed and tightened up gently. We can observe the reading. In pitch scale we are able to see the 5th division. In head scale coincidence 62nd division coincides with the reference line. So the observations are pitch scale reading 5 mm and head scale coincidence 62 division. So we can substitute the value and we will get the observed reading 5.62 millimeter and after correction we get 5.67 millimeter. So the diameter of the given electrical tester is 5.67 millimeter. Do's and don'ts. This is the important part of the experiment. When the screw gauge is tightened up, always use ratchet to tighten up. Once the sound is heard, thereafter we should not rotate. Always use ratchet to either open or close. Don't rotate by thimble. Always use ratchet to open or close. This is the wrong method. And next one, always keep the screw gauge to our eye level. There should not be any inclination so that we can avoid parallax error. So always keep it horizontal to our eye level. This is the right way to hold.